Ishan, can
Yes.
you just guide us on how to go about studying the particular thing, SDWAN?
Okay, okay. Just give me 1 minute, okay? I'll guide you.
Yeah.
All right. Okay, so let me start the recording as well. First, else I'll forget that. All right, guys, welcome you all in the session, right? And probably we are at the end of the year, so it's a good start for everyone. We are going to start in 2024 and we'll finish in 2025. So I hope it is going to be game changing for everyone. So let me share my screen and then we'll start. Okay, so you guys, can you just confirm if you're able to see my screen?
Yes, Vishal, it's visible.
Thank you so much, Idris. Right. Okay. All right. So the Muthu question first is how we should start, right? You were discussing how we should start learning the SD-WAN. Is the same you asking, Muthu?
Like notes or videos or what?
Okay, so definitely the lecture all what I'm going to cover that all are going to be recorded. Okay. So that recording will be available with you. You can watch that recording. All PPT, PDF, whatever I'm going to explain, that is going to be available with you. Also, some ebooks, officially Cisco ebooks, that is also going to be available with you. So that all content, what I'm going to cover, that is more aligned with the Cisco syllabus only. So like whatever the policy template, whatever the VA, CA onboarding process, controller architecture, configuration, troubleshooting, right? Tunneling concept, OMP concept, redistribution, that we are all going to understand as per the Cisco, right? And also as per the industry recommendations, how actual things is going to deploy in the industry, how even cutover and migration is going to be happen. Those scenario we'll discuss. So I believe that would be enough for everyone to just have a good start and they can just go with the lectures. Everyone can go with the lectures and read the documentation, and I believe that is enough to just correlate with the real time scenario as well. So will it helpful for you, Muthu, or something else you are expecting? I believe this is the only way we can start learning by notes, book, and learning material, whatever we are going to provide. Fine.
Yes.
All right. All right, guys. So let's start. So probably today's session will cover, and Wednesday we have the Christmas, so we cannot cover session on the Wednesday. So the next session is going to happen on the Friday. All right. So because in a week we are going to have a three session. So on Christmas probably we can skip that because it's a holiday. So everyone
So
needs.
tomorrow class?
Tomorrow there is no class. Only three classes going to happen: Monday and Wednesday and Friday.
Okay.
Okay. Okay. So let's start, right? So in last session, we just discussed about the basic concept of the SD-WAN, right? We try to understand some real-time scenario, why SD-WAN, right? And we try to understand the benefits of the SD-WAN. I have just given some kind of the background how SD-WAN is just going to help you to just, make network more reliable, more like scalable. Even it is just going to save a lot cost, right? And also going to lower down the complexity. Also, it is going to give the flavor to just introduce the security. Also, it is just going to plug and play where you can just introduce any of the routers without any doing any configurations manually. So we understand fundamentals, but still we have to do a lot of deep dive. So we'll try to understand those concepts in detail in later stage. So also we try to understand what are the challenges we have in the like legacy WAN technology. Like we discuss about the cost, right? Operations, complex, scalability, disjoint solutions. There was not similar kind of solution which is running over the every branch, every locations. So we have to deploy, customize some solutions for the branch basis, some of the data center location basis. We are running some kind of the protocols in the LAN and the WAN, somewhere the static routing, somewhere the BGP, somewhere the different attribute, some might be the different attribute for the inbound and outbound manipulations. But in SD-WAN, we have the single fixed kind of solutions. We can just, redistribute the routing protocol in a single routing protocol, that is OMP. So in LAN, whatever you are learning, but when the sending the route to the any WAN transport to any other branch location via the controller, we have the single routing protocol, that is the OMP. So basis on that, we're just, exchanging all the routing communications. Also, fragmented security, because we have to deploy the different firewalls in a LAN section or maybe data center sections, and based on that we can just uh, control the inbound and outbound traffic based on the company policies. But in SD-WAN, we have the integrated solutions where all security and next generation firewall is available. And based on that, we can simply enable the services, enable the feature, or might be configure the firewall rules. And it is going to help similar kind of the what other firewall can do for the any kind of the restrictions on the controlling the inbound and outbound policies. Additionally, in legacy WAN, we don't have any flexibility to the any routing based on the applications. So that was also overcome by the SD-WAN, because we have the feature that is application aware routing, which will do the discussion in detail later stage how the application aware routing is going to be happen. And also, if you want to integrate the cloud SaaS application, IaaS application, or any third-party private public cloud, that is a very easy to do via the SD-WAN solution. But if you talk about the legacy WAN, we have a lot of complexity, and the even cost is going to be there. So we discuss few of the scenario, but still we have to discuss a lot scenario, and based on that, we'll try to understand how this all overall SD-WAN is going to overcome the most of the problem which was available in the legacy WAN solutions. Now let's understand SD-WAN architectures, right? So what we'll do, we'll compare the legacy router architecture, and we'll try to compare the same architecture with the SD-WAN architecture, right? We might be have the SD-WAN router, that could be the virtual router, or that might be the physical router. So let me just give you some idea, then I'll back to this slide. Just 1 minute. So where it is? Just 1 minute. Let me see. Okay. So if you guys just, get an idea what is SD-WAN. So SD-WAN is like a software-defined networking. And in industry, we have a lot of vendors available who supporting the or who providing the SD-WAN solutions. Probably we have the Cisco SD-WAN, or we can say Viptela SD-WAN, uh, or might be you are going
So
to find the
just one
Catalyst
doubt.
SD-WAN, right? Yes, yes.
Is this a switch or is this a router or what is this?
Oh, what you're asking? The SD-WAN you're talking, right?
Yes.
SD-WAN not a switch, not a router, it's a solutions, right? Like in a WAN, right? This is known as the wide area network. So this wide area network is a concept, right? And to achieve this wide area network, we use that is a router. Without router, we cannot build the wide area network. Similarly, SD-WAN is the concept, right? It's the technology. And if I want to build the SD-WAN network, we require again a router. But these are the SD-WAN router, right? This is not a switch, not a hub. All right, Muthu?
Yes.
Okay. So initially, when the SD-WAN was introduced, so Cisco itself have the multiple flavors like Cisco, Viptela, Catalyst SD-WAN. So I'll discuss what are the three flavors. But apart from Cisco, we have the multiple vendor. Like we have the Silver Peak, we have the Versa, we have the Carto, we have Zscaler, we have the Fortinet or FortiGate, the same thing. We have the Palo Alto, we have the Nokia Nuage, we have some Velo Cloud. A lot of vendors are available. So all are providing the SD-WAN solutions. But which vendor is the most popular? That's going to be, more useful for the engineers to just upgrade themselves and learn the technology, and based on that they can just go and market and get the high paid jobs. So if I compare with the market research, so few of the vendor might be the Velo Cloud, Versa or Cisco. They are the like kind of the leader in the market. You just go and read the Gartner Magic Report. So there are 3 and 4 vendors available which are the leader in the market. But why Cisco is still so much popular? Even the Velo is there, Versa is there, Fortinet is there. They are quite popular also. But Cisco itself having a very high market, cap, right? So many of the customer across the globe, if you think about, they are using the Cisco devices. So if I have the more customers, so probably I am able to easily sell my product, right? More and more. So if I'm going to easily sell my product more and more, then if more product are available in the market, then more engineers requirement is going to happen. So that's why everywhere, every organization probably are going to find that Cisco SD-WAN engineers requirement is always going to be higher than other vendors. That is one reason. Another reason, if you are going to learn any of the SD-WAN, another SD-WAN learning process is going to be very easy for you, right? So why not you're going to learn the popular one, right? Which having the very high market demand. So let's suppose you learn Cisco SD-WAN today, and tomorrow you have chance to learn the Versa or might be the Velo or might be the Fortinet. So at least you can correlate what was happen in the uh, Cisco SD-WAN and what is happening in there and what is the similarity we have. So most of the things is going to be similar except few things like you working on the Cisco router and you working on the Juniper router or might be the Alcatel Lucent router. So all router having the same concept to configure the static routing, same concept to running the OSPF, same concept to run the BGP, but might be Cisco having a different command line to do the configuration and troubleshooting, and Juniper have a different command line, and Alcatel or might be some other router having a different set of the command to just run the configuration and all. So similar in the SD-WAN also, this is going to happen in the same way. So if someone is talking about the Cisco SD-WAN, Viptela SD-WAN, or Catalyst SD-WAN, you don't have to worry. So earlier, let me give the history. Viptela was the company, and this was the company. I'm just talking unofficially. The people who working in the Cisco itself, they separated themselves and they created the company Viptela. And that time, Cisco doesn't having this kind of a solution, the SD-WAN solutions. They were running some different technology, WAN technology that was intelligent WAN technology. But those people who separated from the Cisco, they build this SD-WAN and further they sell out this solution to the Cisco, right? And then Cisco again rebrand that and they also build the capability to ASR, ISR router and CSR router by just upgrading the images. And then they integrate it with the Viptela and Cisco together and start selling because they have the very good marketplace. So till 2020 till 2022 it was like it was working in similar way, like everything was going good. And in after 2022 2023 they just changed the name, right, from Cisco Viptela to Catalyst SD-WAN to just do the rebranding. Nothing was changed, but something happened like VManage has been changed as a manager, VWant change as a validator, and VSmart changed as the controller, and the VEdge and CEdge has been changed as a WAN edge router only. So I'll discuss how things has been changed, but only rebranding was done. Rest everything is on ground is going to be same. All concept is going to be same. So now there is no Viptela, there is no Cisco. If you're talking about the Cisco SD-WAN solution, that is a Catalyst SD-WAN. That's the only solution I have. But everything, whatever in Viptela was there, Cisco, that is same like concept is running still there, right? So if I talk about, let me go on the little bit downside. So in the solutions, we have the control plane devices, we have the management plane devices, we have the data plane devices. So you can say we have the VManage, VSmart, and VBond in the VH routers. So still in the SD-WAN, we have the router, right? So VH router. This VH router is Viptela edge router. There is another router that is known as a CH router. So this CH router is basically Cisco edge router, which is the ISR router, which is the ASR router, and might be the CSR router. So these are the router which can be work as a normal router, and after upgrading the SD-WAN images, it is start working as the SD-WAN router. So even we in the lab, we are going to integrate one of the CH, and based on this CH, we are going to see how this CH is going to be integrated and how it is going to build a tunnel with our fabric. So we'll see that also, right? So what I mean, so in this section also we have the router, but if I just compare with the legacy router with this router, how it is going to make a difference, we'll see after a few minutes, okay? Now, if I just talk about the deployment method a little bit, if I want to deploy the router, there is just two type of component in the SD-WAN, especially Cisco SD-WAN Catalyst. One is the controllers, which have the different devices. We want VManage, VSmart, right? And one other device is the routers. So controllers are always going to stay in the cloud. Means not only cloud, it could be the private cloud or public cloud or might be the your hosted data center, but it's in a virtualization environment. This is the correct word. So these are the not a physical hardware. So if I want to use the controller, it is always going to be somewhere in the virtualizations. There is no hardware you have to purchase from the Cisco or Biptela. They never like build any hardware. So this could be the on-premises. You have the physical server. You can just deploy in the ESXi. Their instances is going to be there. You can just run in the VM, and this is going to be supported. Another is the hosted. You can use the services that is the Azure and the AWS. Based on that, also you can host the services. But if we talk about the routers which is available, this could be the physical routers, and we have the model like VS1000, VS2000, VF5000, and some VH100 as well. So if you want to build your WAN site, might be you're going to purchase the physical routers, or if you don't want to purchase the physical and you want to run the instances in the virtually, it is also possible. So this VH routers or Madvis CH routers can be even deployed in the ESXi and KVM, means virtualization. It is also possible. So routers have the flexibility of the both flavors. It can be deployed in the router, in the virtualization, and the physical as well, right? But controller, it's always going to be virtually only. So let's come back to again on the PPT. So you guys see one of the router, which is the 760. It's a quite old routers. So let's think about if I want to do any kind of the communication via this router, how the communication is going to be happen. And if I want to do the same communication in the SD-WAN router, then how it is going to be happen, right? So we'll try to understand the basic concept, and then we'll try to go a little bit advanced in our later sections. So let's think about, we have some kind of the like requirement, very basic requirement. We have one of the PC, and this is another PC. There's a PCA, there's a PCB. Just think about it's have the IP 10.10.10/24. This having IP is like 12.12.12.12/24. Each PC directly not going to connect to the router, but just think about it is connected to the router. Okay, directly these two RJ45 cable connected there, right? This is RJ45. Cables are connected. So, Ajit, you want to ask something? You have any question, Ajit? No? Okay. So let's think about this PC want to talk to this PC too. And you have any router, just ignore the model of the router, how the communication is going to happen and how the packet is going to flow. So initially when PC is going to talk, they have the gateway configuration. So this is going to like punt the packet on the interface where it is connected, or my the gateways there is connected. So let's say the gateway is connected .1 here. For this also 12.1 connected here. So first it is going to hit to the gateway, and after hitting to the gateway, this all router have the different kind of the like functions. So you can see one is the IO modules, one is the control plane modules, another is the switch fabric. So we just have to understand the role of all three kind of the modules. So IO module is basically your input output modules, right? Control plane is your brain, right? Which maintain the routing table. And switch fabric is, just think about the mediator, right? Who just combining the control plane and your data plane, that is IO modules. That is a switch fabric. All right. So if any packet is going to receive, that is your input packet. If any packet is going to be sent, that is your output packet, or might be the ingress or egress. You can just think about input or output it's going to think about. So once the packet is going to hit in this any IO module, what IO module is going to do that? They don't have any brain, right? They don't have any brain to process directly packet from this interface to this interface. They are not intelligent like enough. So what they have to do that they basically consult to brain. Hey brain, can you just tell me how can I reach out to this particular destination? So your packet is going to be created. In this packet, you're having a source of 10.10.10, but destination 12.12.12.12. So based on that, they will reach to the brain, but who is just combining this IO module in the brain? This is switch fabric. So switch fabric is just, you think about the ASICs. This ASIC basically line card is going to be inserted, and this is also going to be inserted, and then they are going to make a closed circuit. So based on that closed circuit, your line is going to be created, and once this packet is going to reach the routing table, your brain is going to tell which is your next hop interface where you have to send the packet out. Based on that, you are going to send the packet out, and when reply is going to back again, you are going to back to this particular PC, and you have to follow the same process. So what I mean to say means still my router having a three major component. One is the IO module, one is the brain, the control plane, one is the switch fabric. And based on that, we are doing the all entire communication, right? So if I have the thousands of the routers, or might be I have the hundred of the router, every router they have the individual brains, right? And every router have the individual switch fabric, and every router have the individual IO modules. You all agree? So if any
Sir,
IO
one
module is,
thing, sir.
yes, please, Muthu.
Could you repeat what a switch fabric does, sir?
So switch fabric is nothing. Let's suppose I have the control plane one unit, one is the IO module. So if they want to communicate, this is just bridging them together. Means they are building the circuits, they are building the connection from the backplane of the A6. You understand?
Okay, this is just a physical connection between both of
Yes,
them.
this is just the A6, right? And based on the A6, you're just building the connections. The line circuit is going to build, right? Let's suppose you want to, this is the one section of the river, this is the another section of the river. You want to cross the river, so you require the bridge, right? So you need to build the bridge, right? So you can just cross the river. This is your switch fabric. This act as a transporter, mediator. All right, Muthu?
Got it. Thank you.
So what I mean, right? So in every router, we have these three modules always going to available. And based on these three modules, we have to build the communication end to end. But when I talk to SD-WAN, right? So in this section, what I just explained, this is known as the closed box architecture, right? So closed box architecture means everything we are doing in the closed circuits. Means we have the individual brain, we have the individual IO module, we have the individual switch fabric. But when we are going to decouple each and everything, means we are going to place switch fabric one place. One place we are going to put the control plane, and one place we are going to put the IO module. So we are just splitting the box, means we are going to open the box, we are going to decoupling the box, and based on that, we are going to build a new kind of the concept. And when we are going to do that new kind of concept, that concept is known as the SD-WAN concept. Okay. So let me explain how it is going to happen. So you just remember this diagram, okay? Or you might be take a snip with you and just take as a reference. So I'm just going with the SD-WAN architecture. This is my closed box architecture. That is a normal router. And this is my SD-WAN architecture. In this SD-WAN architecture, you can see that we have again a control plane module. We have again a switch fabric. And again, we have the IO modules. All three sections which we have in this box, it is available in the SD-WAN architecture. So exactly the same way router was working, our SD-WAN is going to work in the same way. Nothing is going to be changed. So what new things we are going to see here? Let's understand. So first understand, in the one single router, we have the control plane, which was your routing table, right? So every table, every routing decision was going to happen with the routing table. Switch fabric was where ASICs, right? Which are going to build the all kind of the circuits between the routing table and the IO module. And your IO module was your physical interfaces, right? But if you talk about the SD-WAN, again your control plane is going to be routing table because we have the controller. We have the switch fabric. Here is ASIC, but here we have the your ISPs. ISP means your lease line, your MPLS circuit, your internet circuits, your 4G, your 5G circuits, whatever. That is going to act as a switch fabric. And IO module is your actual, not a physical interface, actual your routers. Routers means you have the VH routers or might be the CH routers. So router are going to act as IO module. This is the basic difference we are going to find that, right? So you might be having question ki router we have here. So does this router not have the brain? Means the routing table not have the ASICs, not have the IO module. Exactly, they have the IO module, they have the ASICs. I'm not going to deny. But if you talk about the routing table, brain, that brain is not going to associate with these routers. They are going to be brainless router. Why I'm going to talk the brainless? Because if let's suppose the same scenario, if I have the one router here, I have the another router here, right? And here is the PCB connected, here is the PCA connected. And again, the same topology if I want to make here. This 10 by 10 and 12 by 12 by 12/24. If these two routers want to communicate to each other, how the packet is going to flow? They will reach to the
So I cannot.
controller.
1 minute.
What, Muthu?
Could you write in it above because I'm not able to see the full screen. I'm seeing on the phone. Sorry.
So why are you watching on the phone? You should go in the watch on the laptop.
Oh, sorry,
Muthu,
sorry.
you should watch in the laptop. Please watch on the laptop. If you're watching on the phone, then it's going to be a great problem.
Okay.
Okay. So we have the same scenario 10, 12, right? So basically, we have to make the communication. So now again, the packet is going to punt on the physical interface on the router, but this router is a brainless. They don't have the routing decisions. So what is going to be happen? They must have to connect with the brain first to get the routing decisions, right? So brain is might be located in somewhere in a different location, geolocation, not in the same routers. Might be your router is hosted in the India in Mumbai, and the brain is hosted in the USA, or might be the Singapore, might be the other Asia Pacific country. So in that case, how my request is going to reach there? So we have to use the transport, that is MPLS, broadband, 4G, internet circuits, and those are basically the going to act as a switch fabric and going to build the communication from the end router to the brain to take the routing decisions, right? So this is how your SD-WAN architecture is going to come in picture. So in this scenario, every request which is going to happen, they will consult to get the routing from the brain. So might be there is a question, if the brain is going to dead, then how it is going to happen? Do we still require the like it means do we require another brain, or might be the complete routing is going to be dead? So the technical answer is, even your brain is going to be dead, right? I'll talk with the real time use case also. I'll show you how it is going to happen. We'll down our controllers and we'll see how this is going to be act in the real time scenario. But in theoretically or also the practically, even brain is going to be down. It will give the default some certain time, right? Might be 12 hour. This is a default time. So before 12 hour, if you are not going to restore your brain, right, your entire fabric is going to be down. Means it is not going to further support you. But before 12 hour, everything, whatever the pre-configure means, once the brain given the instruction, the routing decision for this particular router, that is going to perfectly work. It is not going to update any new routing, but whatever the legacy cache routing available, based on that, they are going to support. But if your time is going to, that is known as GR time, graceful restart timing. If that is going to be expired, then your entire fabric is going to be down. So that's why I'm saying these are the brainless router. They are going to support with some certain conditions, right? So this is the decouple architectures where we are distributed our control plane, we distributed our data plane or switch fabric, but they are technically going to club together, and based on that, they are going to support that. So what is going to happen? Why this controller? So whatever the router is there, right? Whatever the router is there, we simply everyone having their brain, that is a routing table. So simply what we are going to do that, we are going to remove the brain, we are going to put the all brain together in the central location. So all brain are going to put the central location so that every decision is going to happen centralized and effectively, and that is known as the controller, and technically it's a VSmart. So if I am going to use the controller, right? So if I am going to use the word the controllers, so controllers having a three component. We have the VSmart, we have the VManage, we have the VBond. These all three are the controllers. But someone is going to ask you the controller, especially for the controller. That is the only VSmart. So don't be confused, right? So in generic, people ask what is the controller. So you just have to go and explain what the VSmart, VManage, and VBond. Further in the controllers, this is the only controller, right? This is your management tool, right? Where you just go and it is known as the NMS basically. And this is your orchestration tool, which is just going to orchestrate or might be the validate all the fabric, which is just going to come to join the fabric. So we'll discuss what is the V1 later and the VManage, the VSmart, right? So is it clear to everyone? Any question about this closed box architecture and the open box architecture? Any doubt or all good?
All good.
Thanks, Zach. So let me give an idea, right? Let me talk about more about the controllers, right? So let me minimize it. Okay. So see here, the same traditional WAN, what I explained right now. In traditional WAN, we have the management plane, we have the data plane, that is IO module, and we have the control planes. So single routers having every three planes available, and every routers having their own individual decisions to take any routing decisions to go in and out. But if we just go with the any Viptela secure or Cisco SD-WAN solutions, this has been changed. And you can see we have the orchestration plane, we have the management plane, we have the control plane. So control plane and controllers. So control plane, only one device is there. That is a VSmart. And if I talk the controllers, all three are going to be there. So orchestration plane is the VBond, management plane NMS is the VManage, right? So these are the three component. They have the different plane, and we'll understand what is the functionality of these three component. But if I talk about the actual data plane, that is your actual router. That is a VH router or that is a CH router, right? So this all name was there till last year it was there, right? But once Catalyst SD-WAN is introduced, right, these all names has been changed even. So VBond become the validator, right? VManage become the manager, and VSmart become the controller, and VHCH become the VANage. So you don't have to be confused, right? If someone is going to ask what is the validator, so always remember validator is the VBond. What is a manager? Manager is the VManage, right? What is a controller? That's a VSmart. What is the VANage? It's a either VH or it's a CH, right? So these are the component. So data plane devices always going to be your VANage, VSCH, control plane your VSmart, management plane your VManage, and orchestration plane your VBond. So these three things we just have to, or four things we just have to remember. Now, if I just go and talk individually feature of these all component. So First, we'll discuss about what is the VBond, right? And why this VBond is very important. So, guys, see, VBond is a very important because they have the very special feature. Without VBond, no one can able to join the fabric. Just take an example. You clear your interview for any company, right? Your manager, means hiring manager know about you. HR very aware about you, right? They know you are very like talented people and you are just going to join us. You can prove each and everything, but still when the date of joining is going to be happen, they will ask you your credentials, and your personal credentials might be related to your identity proof, your certifications, your academic credentials, and they will not only validate by themselves during the onboarding. In additionally, they will hire the third party agency to do just your all validations, right? And once the validation is going to be success, then only they are going to onboard you in the company. The moment your validation is going to fail, you are not going to allow to join the company, right? So means zero trust. Means physically they know you like you are very good, everything is fine, no problem. But still they are going to validate in backend. Similar way, this zero trust model is going to work in the SD-WAN fabric. Any device in any topology, let's suppose this is my new router, right? This SD-WAN router, this SD-WAN router want to join this fabric and want to talk to this. So before they join the fabric and talk to this router, they have to prove their identity, right? To whom? With the VBond. So they have to prove to identity with the VBond, that is acting as the HR of the company. And if the VBond is going to be happy with the credentials, then only he or she will going to introduce with the VManage, VSmart, and then you are going to reach to the other VH router. If you fail to prove your identity at the first place, you are not going to work or not going to like make any communication with the any other branch location. This is the primary role of the VBond. So it's a very powerful, and without it, you cannot make any kind of the connection with the any your SD-WAN devices. So that's why it is known as the orchestration control and the management plane control, right? Because it is just going to introduce your any kind of the management plane devices, any kind of control plane devices, and then further you are going to reach to the any kind of the routers. So that it is going to orchestrate, it is going to drive the your all communication or joining the fabric. The first point of the authentication, similar to the whitelist model, means you just have to prove your identity, then only you are going to make the communication. Also, this VBond is going to distribute the list of the VSmart VManage to all VS devices. Means this VBond first it is going to authenticate. Once authentication is going to be happen, then only this responsibility to distribute the VSmart and VManage devices to all VH router. Means whatever the router is there, once they prove their identity with the VBond, he will give the information about this and this to this, right? Most important and most like interview based ask question, NAT reversals, right? So it have the special feature which is going to do as a NAT reversal. So VBond also act as a stun server. So what is the stun server? That is known as the session traversal utilities for NAT, right? So this is the NAT, that is a stun. So stun is session traversal utilities for the NAT. That is known as the stun server. So what is happening? Most of the SD-WAN scenario might be you're not going to find the NAT reversals. And some scenario you're going to find the NAT reversals. So first understand what is the NAT reversals. So let's suppose this is your SD-WAN device, right? This is the VS devices. And you might be taking the ISP here directly. This is the ISP A. This ISP A is connected with the ISP B here. Sorry. ISP B. And this is another VH. This is 2. This is branch 1. And this is the branch 2. So you are going to take the direct public IP here, direct public IP here from the ISP. So they are just going to build a tunnel DTLS, TLS, and they're just going to make the IPsec BFD session. There is no problem. But just think about you introduce one of the router here and you terminating public circuit here, means public IP is going to be here, right? And here you are building the private IP connections, right? And then you have to build the TLS, TLS connection with the private and public. So something is unusual, right? Generally we not do, but we might have some scenario where we have to do that. So if I have to build that, then we have to use the NAT-T. This is the NAT traversals. Means we just have to translate our public to private, whatever configured on this router, and we just have to maintain the NAT table. So that's why VBond is also act as a stern server, and the basic responsibility of the stern server, basically, it is going to act as a NAT traversal, and it is going to maintain, right? Whenever TLS GTLS connection is going to be started. So VBond, basically, there is a two concept, VBond and stern. So stern having two role. One is the stern client and a stern server. So we have the stern client and we have the stern server. So your VBond is always going to act as a stern server and your VH is always going to act as a stern client. So what is going to be happen? Any packet which is coming from the VH routers and they want to build a DTLS tunnel. So they have the headers, right? So based on that header, they are going to write the outer IP address, means whatever the exit interface, they have the interface IP address, they are going to put the IP address in the header, right? So based on that header IP address, and also they have the payload. But if the connection is going to reach when the VH router send the DTLS connection, right, request to VBond, right, it is going to write the interface IP in the outer header, and also it is going to write the same IP in the payload. Means the whatever the IP address they write in the outer header, they're going to write the same IP in the payload. Means the both IP is going to same in the normal scenario if this router is not going to be there, right? But if the NAT is going to be happen, so my outer IP is going to be always replaced with my inner IP address. So that means VBond is going to understand there is a end, means NAT traversal is there, and that's why they are going to maintain the NAT traversal entry, or means NAT translation entry in the their record. So if they have to just do the retranslation, they can do that. So it's all about the payload IP and the your outer IP. If they're going to be same, then there is no NAT. If they are going to mismatch, then there is a NAT. So that functionality is also going to done by the VBond. So that's why it's known as the stern server. So that's also a special feature available in the Cisco VBond, right? So this is the first line of the authentication, right? First point of the authentication, and also it is going to introduce the information to the VH router about the VSmart and the VManage, and they are going to facilitate the NAT traversal. And this is act as the stern server that is known as session traversal utilities for the NAT. And the only how you can identify if your outer header and payload IP is going to be same, then there is no NAT. If they are going to mismatch, then there is a NAT, right? This is how it is going to happen. Now, if I go and talk about the another controller, that is the management plane. So what is the management plane, guys? So management plane device is the VManage and also known as the VManager. So what is the VManager and what is the VManage? So this VManage is the single pane of glass. Why single pane of glass? Without this VManage, you cannot do any kind of the configuration, any kind of the troubleshooting, even you want to onboard your VBond. So before you onboard the VBond, you have to make sure VManage is live and it is authenticated by the your VBond, right? And the server certificate is going to match. So then VWAN and VManage are going to work together and REST authentication is going to happen after that. But you have to start always building that like configuration with the day 0, day 1 and day 2 from the VManage. Then you can just start building the VBond. They will have the same certificate, so they will just validate to each other. And then entirely we can onboard the rest of the fabrics. So that's why you can see in the topology, we'll do the step by step all configurations. Hold on. So you can see we have the VManage and we'll do the how the certification is going to happen, how the controller is going to be configured, right? And we'll build step by step all the things. So VBond is something, VManage is something where we can have the single pane of glass dashboard. We have to do the all configuration, policy creations, troubleshooting, right? And rest onboarding process we can do via the VManage. They have the multi-tenant capability. What does in multi-tenant capabilities? So multi-tenant means like let's suppose you are supporting the shared customer. So what is a shared customer? Or might be a shared resource, not a shared customer, shared resource that is going to be shared by the multiple customer. Similar to the VRF means suppose you are the ISP and you have the single router, but on the same router you are sharing the different routing table to different customers, but they are completely isolated. They are not having the interference from the one routing table to another routing table. Similar way, VManage also, if you want to create the single VManage for this different customer, if you want to save some cost, not dedicated VManage for your company, you can do that. And based on that, you can enable the multi-tenant feature, and that is completely instance. Your instance is allowed to your company, and another company instance is going to be allowed to another company. So it's similar to the VRF, nothing more than that. So that's a multi-tenant feature is also there. Centralized provisioning by sitting on that particular VManage, you can do all the configuration. Policy template, we'll see how the policy, complete traffic engineering, like we have done the policy configuration, the BGP, OSPF, MPLS, right? We have done a lot of traffic engineering routing. Similar way, based on the policy in the SD-WAN, how the traffic manipulation is going to happen, how the inbound, outbound traffic is going to be manipulated, how we can do the hub and spoke topology, how we can introduce some VPN-based OMP route, how we can exchange one VPN route to another VPN route. Similar RT and RD we are doing in the MPLS, right? So those all manipulation will see that if I want to do the preference like with this local preference, eighth path prepend, right? How we can do where the localized policy and centralized policy. So those things also will configure on the vManage, and branches template, that is a device template, feature template, CLI template. So we'll also configure from the vManage, right? So any configuration, troubleshooting, you can see monitoring, software upgrade process, rollback, role-based access. You want to integrate with the netconf, restconf, like a third-party integration with the API. That all possible with the vManage, and we can do all integration with the vManage, right? They also going to be highly resilient. Why highly resilient? In case my one VManage is going to be down, my another is going to be take role, right? So all controller are going to be highly resilient. That is a recommendation. Lab, we are not doing the highly resilient because it's going to kill our resources. So we are here for the learning. The same configuration is going to there in redundant scenario. Nothing more than that, right? So any question about the VManage guys, or we bond, or we are good? Shall I consider we are good? Muthu, you okay?
VManage is like suppose we have MPLS, VRF.
No,
So
no. MPLS, they have the one feature that is a multi-tenant feature. So VManage is the one of device. Okay. That device having the one special feature multi-tenancy. That's I given the example. It's similar to the VRF. Okay, Muthu.
okay, so
So in any network, so we can have only one VManage or two VManage. Is there any limit to how many VManage, VBond, VSmart we can have?
Ideally, we build a clusters 2 or 3,
Mm-hmm.
but there is no such limitations. And I believe there is no even documentation we have limit. But yes, ideal scenario might be you can go with the 5 cluster, 3 cluster, not even more than that.
Okay.
I have never seen that. So
Okay. Okay.
ideally, like any customer, like medium range of the customer, they have the two regions. Might be they are supporting for the APAC and the EMEA region, right? So they are
Mm-hmm.
going to use the two controllers. They are in the three region like APAC, EMEA, US. They have the three controllers. They are going to build a different control like APAC resiliency they put the EMEA resiliency they put the US, and US put the
Mm-hmm.
APAC. So like that.
Okay. Okay.
So it 3, 5, even I have never seen 5, but 3 I have seen that for the few customers. Okay, but 2 is like
Okay.
quite frequent. Okay, Bhavana.
Mm-hmm. Okay.
All right. So moving next, right? Uh, Control plane, right? So this is the brain of the SD-WAN. So every device is brain, right? But one is the management brain. They just have doing the configuration, pushing the configuration. We want is just authenticating. But if you talk about the fabric traffic engineering, so that is going to done by the control plane device. That is a controller, and that is a your VSmart. That is also known as the controller. So this
This
is the
is a rib, right?
yeah. Sorry,
It's like a rib table.
it's like a rib.
I'm sorry.
What Muthu? Yeah, go ahead. Go ahead. Please ask. What are you asking? It's like
Routing information
yes,
basis.
routing information. Absolutely right. Routing information. So this VSmart is just going to like explore all the routing informations. So that's why you can see the first line is talking about facilitate the fabric discovery. Means anything is going to be reached from anywhere, right? So this is something who is going to tell you how to reach that. So it is going to like give the or disseminate the control information between the router, or they will help to facilitate how to reach from one place to another place. So all routing is going to be like segregated or send it toward the VH router via this control plane device, that is a Cisco VSmart. Also, this is responsible for the all policy integration. Means if I want to integrate all the policy, means if I want to create the app aware routing policy, you want to create data policy, control policy. So this is the only device where we can create all the policy, and based on that policy, we can just make sure which direction my traffic should be forwarded, what priority need to be give, what preference need to give, what is my hub location, how my end router, my manipulation is going to happen based on the OSP or BGP. That all is done by the localized policy or centralized policy. So this VSmart is very responsible. Uh, Let me clarify one thing. There is two type of policy. One is centralized policy, one is the localized policy. We'll do the deep dive later on. But this VSmart is more about the centralized policy, no about the localized policy. Localized policy always going to hit to the end router from the VManage itself. So I will explain how it is going to happen. So if someone is going to ask you, if I want to do any kind of the manipulations from VH point of view for the any BGP OSPF or static route, can I push the policy from the VSmart? The answer is no, because those policy are limited to the local box, right? They are the legacy routing. Still, they are going to be redistributed. They are going to do all kind of the manipulations, but it is not a fabric routing. Fabric routing is just OMP. So any OMP level manipulations we have, that is absolutely doable via the VSmart. Any policy we are creating, like VPN members, VPN level, we are creating control policy, data policy, that is doable. But any localized local box ACLs, any BGP, OSPF, that is only done by the localized policy, and which is going to push via the VMAN. I'll explain how it is going to happen later on. But sometimes people always ask in the interview such kind of a question. So probably you better understand, right, how it is going to be answered. So you can see such as the service chaining, multi-topology, multi-hop, it is also dramatically reduce your the control plane complexity. So basically it is a single routing protocol. So definitely you don't have to do a lot of manipulations. It's a very straightforward OMP is going to run. So your single routing table, some few manipulation is going to help to just, how to do the manipulations and how we can just achieve our routing decisions. And this also going to be highly resilience. Okay. So this is all about the Cisco VSmart, which is going to help in terms of the fabric discovery and the routing region policy enforcement. Now, last but not least, with the Cisco Edge router, right? So this edge router is actual router which is just situated at the every branch location. So you can see we have the branch 3, we have the branch 4, we have the branch 6, we have the branch 200, we have the branch 5. Every locations we have the edge routers. Right? These routers are going to connect your LAN devices. You can see this is a LAN, this is a LAN legacy router. So what is going to happen in WAN? In WAN, we have the different set of the communication, but in LAN, we have the legacy of the communication. Means probably what we can run here. If I want to run, probably I can run the one LAN as a static route, right? One I can run as a BGP, and this I can run as the OSPF. I'll actually do the same thing in the lab also. So in the all three LANs, we'll explore all major three routing, static, BGP, OSPF, and we'll see how static is going to integrate with OMP and how it is going to be distributed in the OMP. We'll see how OSPF is going to happen and how BGP is going to happen. So there are a lot of catchy rules which you have to understand in terms of the advertisement routes in the OMP to the OSPF, OSPF to the OMP, BGP to OMP, OMP to BGP, and static route how it is going to advertise in the our OMP. So we'll see all scenario and we'll try to understand in very detail, right? So what I was trying to make a point here, I was trying to say that if I'm going to talk about data plane devices, so these WAN edge router are responsible to connect with the traditional routing protocol like BGP, OSPF, static route, VRRP. So anything you want to do that, it is possible. This also going to establish the control connections with the VSmart. So I'm going to talk that is multiple type of control connections we have. So which control connection they are going to establish that also will understand. So they are talking about the OMP, but we have something more than this also. Okay. They also talking about provide the secure data plane. So this is again required tunnel. This is the IPsec tunnel. Okay. Inside of the IPsec tunnel, we have the BFD tunnel also. So that also I'm discussed. But you see, provide the secure data plane. They provide the control plane, OMP. They also implement the data plane and the application routing policy. So we'll discuss how this localized policy is going to be implemented. We can export the performance of the interfaces, any application as statistics, right? If I want to export, I want to see the real time what is happening, that is also possible. And we can connect with the any IGP routing protocol, right? And also it supports the zero touch provisioning, and they have the multiple interfaces like 100 MB, 1 GB, 10 GB. So this is how it is going to be look like. Now, anyone have any questions, or shall I let me explain something else about the control connections? Any question, guys? Or everyone happy? Jay,
All good.
Muthu?
Actually, I've
Oh,
read in the Cisco documentation like the maximum number of the VManages you can have is 6. They have given it in the site also, like for less than 1,000 devices, you should have 2 SD-WAN, and then for the 10,000, you need to have 6.
yeah. So I think 1024, right? There is a two set of device, right? Not one
Ye-
1024, right?
Yes,
Yeah.
actually, earlier we discussed, like the maximum number of there is no maximum number of controllers for the, but Cisco has said it's 6.
Okay, thanks for correcting me, Jay. Actually, I have seen maximum five realistic, not three or five. I have seen like maximum because that much branches I have not seen. So probably thanks for correcting. So I will just update my also knowledge. But in real scenario, I have seen like customer running for the three or five maximum, right? So that's why I told like we can go with the cluster either two, three, or five. So still saying the 6. And how much maximum they supported? 1,000, 4,000 or 10,000?
10,000.
10,000. Okay. Can you send me the link also so I can just take a note? If you just
I will paste it. Okay, I will
yeah,
paste it.
yeah, just
Initially,
paste it.
actually, I was going.
Yeah,
on
please,
a-
please do that. Okay. Probably I missed that somehow. So by default, there is like if one set have the controller, so they support 1024, right? If I'm not wrong. And if you go the maximum, you just have to upgrade the our controller also. So no worry, I have one document. I'll show you how the mapping is going to look like for the region wise and the branch wise, and how many connection you can build. So that all available, right? And we'll see the documentation. But more realistic, you guys are going to find 2 or 3.
Okay.
Yeah. So I would appreciate your link. Okay, just paste me in the chat.
Yeah,
So
I will
definitely
play
I'll.
it now.
Okay. So guys, see. So I was talking about we have the multiple type of the connection, right? So
Uh,
when
Sorry,
yes,
I have a question. Can you explain, like, maybe in the layman language, like, for example, a new router comes in, like you mentioned about vBond, it it authenticates a new device and the new edge router or V edge router, I think whatever it.
Mhm.
Then what happened next? Like, how it authenticate? Like, how it knows that I need to go to the vBond router
So
or.
we Manjit will do the authentication process. Okay, I will explain all individual authentication, how the authentication process is going to happen. You want like when it is going to reach, what is the information it is going to check, what is the parameter, and then how it
No,
is
no,
going.
no. No, not in that detail.
Uh-huh.
I just wanted to know, like, for example, like, FE install a router.
Okay.
Okay, and how does that router knows that I know need to go to the vBond, or like, and then how does vBond instruct it to like go to the vManage? Like, how actually
Okay,
things
okay,
happening?
okay, 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 okay. Got it. So there is one process that is known as JTB process, right? So we'll cover in that total 11 steps are here. In every steps it is mentioned once the power is on, what is going to happen? Once the connection is connected, then what is going to happen? So we have to cover that. Okay, I'll explain. So we have the complete set of the discussion, 11 step we have to see what is going to happen when the router is going to be turned on and the LAN and WAN is going to be connected. But in layman, let me explain you. Whenever you want to onboard any router, okay, that topic will cover separate, okay? But you want to understand. So let's suppose this is a router and this router want to join the fabric. So there is 3 controllers, that is the VManage, VWAN and the VSmart. So what is the first thing is going to happen? We have two concepts. One is the underlay, another is the overlay, right? So what is underlay? Underlay is your basic IPv4 connectivity. Okay, so this is the required. If this is not available, you cannot form the overlay connectivity. Overlay your like you are going to build the OMP, you are going to build the DTLS, you are going to build the TLS, you are going to build the IPsec, you are going to build the BFD. These are the all overlay. So before you are going to build overlay, you must have the underlay. Means the first prerequisite is this device either via the MPLS, either via the internet must be reachable to the vBond. Clear? So this is a prerequisite. So once it is reachable, right? Then what is the next step? This at the same time, this also needs to be reachable with the all 3 controller. This is the prerequisite. Once they have the reachability and all 3 controller are the fully functional, right? Then what is
So
going to happen?
we define on the VH, like we, let's say we define like V manager router IP
Yeah, I'm
is.
coming. I'm coming. So first underlay you understand, Manjit?
Yeah,
Underlay.
I
So this is
understand.
the underlay is there. Then what you have to do that you have to go on this router and you have to configure your VPN 0 interface. That is under the VPN 0. I will show you the step-by-step process how it is going to happen. Not only theory, we'll see the practical. We have to configure the interfaces, right? Under the interfaces, you have to define the colors, you have to define the other IP details, you have to define the encapsulation, other details. This is the first set of the configuration, right? Second set of the configuration, you're the system configuration. Under this system configuration, you have to tell what is your VBond IP, right? So he will try to reach that VBond IP because you already build the underlay connectivity, right? So you have to define the VBond IP. Other total 5 tuples are going to require the system IP. One is the VBond IP, system IP, your site ID, your host name, and your organization name. So two most important, all 5 tuple are the important. So these are the mandatory things should be there. If anything is missing, you cannot reach to the VBond. So once it is going to reach via these 5 information to the VBond, this VBond is going to validate his serial number plus chassis number. If this device serial chassis number available in his database, then he is allowed to build the tunnel, and then he will introduce the VManage, and then they will further build a tunnel with the VH router. You're trying to understand this one or something else? First, let me know so I can
So
give this.
basically, it will create 3 tunnels, one for the vManager, one for the vBond, and one for the vSmart.
Yes, yes. And also with this router, if you have to, let me, I'm about to talk this only. So let me,
Okay.
you understand this concept or not? What if,
Yeah. Yeah.
okay. So let me tell you, I was just telling about tunnel only. So we have the multiple diode tunnels, right? So we have the tunnels, that is the DTLS tunnel. We have the TLS tunnel, right? We have the IPsec tunnel. We have the BFD tunnel. We have the OMP, that is also routing protocol, that is under the tunnel. So TLS, DTLS, IPsec, BFD. So this router is going to build the TLS or DTLS tunnel with this only. So TLS is basically based on the TCP, and this is based on the UDP. So it's my choice. I want to build the TLS or DTLS tunnel with the VH router. If I want to build DTLS, it should be faster, but they not have the reliability. But most organization use the DTLS only, not TLS. It's a little bit slow, right? So default is DTLS only, right? This also going to build the, this is a DTLS or TLS, either one. This also going to build a tunnel with the VSmart router. This is also DTLS or TLS. This also going to build tunnel with the VBond. But here only one tunnel, DTLS, no TLS. Okay. TLS is not supported by this particular VBond. All right. So 3 tunnel is going to build. Now my 4th tunnel is going to build. If I want to talk with the VH to VH, then I have to build another tunnel. This is known as the IPsec. And under IPsec, inside of the IPsec, we also building the tunnel that is the BFD. So why IPsec, why BFD will discuss. But first understand where the IPsec and BFD. Now we have done this all tunnel information, but where is the OMP? That is known as the overlay management protocol. This is the routing protocol. OMP is the overlay management routing protocols. This OMP tunnel is going to build between VH to VSmart under the TLS or DTLS. Means first your TLS and DTLS tunnel is going to build. Inside the TLS and DTLS, you are going to build the OMP tunnel. Okay. So VSmart is going to build the tunnel with the VH router, and this is your OMP tunnel. If this VSmart building the tunnel with this VH router, this is also going to build the DTLS or TLS, but under they are going to build the OMP, right? So VSmart to VH OMP, VSmart to VH OMP, and if I have another VSmart, right? They also build the TLS, DTLS. Under this, they are going to build the OMP. So OMP always, there is no OMP between the VSmart to VBond. There is no OMP between the VBond to VManage to VSmart. Only VSmart to VSmart, VSmart to VH, or might be, not might be, it's a fix from the VSmart to VH router, right? So this is the only conditions we have. Is it clear till now?
Yes, actually, you are saying OMP will be built under the DTLS, but DTLS is itself an underlay, right? OMP is then overlay.
No. No. DTLS, TLS is the layer 4 protocol. This is not underlay.
So like OMP works above the DTLS. First DTLS will be there, then there will be an overlay protocol, right?
Let me show you. Let me show you. Understand. See, this is your OMP tunnel.
Yes.
Let me show you this diagram so you can understand. Underlay is basic IPv4 reachability. Okay.
Yes,
Simple.
done. Right.
IPv4, IPv6. This is the underlay.
Yes.
Nothing more than that. Okay. Anything layer 4 or layer 7 that is over. So see, this is the your underlay. Underlay is IPv4. Then you build your TLS. This is your TLS and DTLS tunnel.
Okay.
This is the
Okay.
layer 4 tunnel. Under
Okay.
this tunnel, we are building another tunnel that is the OMP tunnel. So
Okay.
both are the overlay, not underlay. Okay, Jay?
Okay, got it.
Got it? And then you can see we build the first IPsec, right? You can see green one is the IPsec tunnel. Under the IPsec, we are building the BFD. Okay?
Okay.
So the OMP is going to build between VH to VSmart or between VSmart to VSmart. No VH to VBond, no VSmart to VH, VBond, VManage, this OMP is not going to build. But IPsec is going to build only from the edge to edge. It's a CH or VH. Or BFD is going to build only between the edge to edge. DTLS is going to build with the all controllers. Clear?
Yeah.
Okay.
What?
So what we can do, right? In Friday, what we can do that? We'll try to build this control plane on the Friday class, okay? And after that, we'll try to build underlay connectivity. And we'll see how this all is going to build a connection, TLS and DTLS. And then we'll have the more debate on it and we'll try to understand more on it, okay? So because if I start doing the configuration, it is going to take a longer time. So probably we can close. If you guys any question, you can ask me right away. Or on Friday, we can do the more about the configuration and then we can have the further discussion on it. Will it fine?
Yeah.
Yes.
Okay. So please let me know if you have any question, guys.
One last query. So VWAN के साथ only DTLS connection होता है ना, not TLS?
That was yes. So only there is two things only. This only required the DTLS, right? And one more thing. This is the temporary connection, not the permanent. These all tunnel are the permanent. So I will tell, right, how it is going to look like. All tunnel are permanent, but we want is DTLS. It's just temporary connections. Once onboarding is done, your job is completed. It will terminate the connections.
So Vishal, while creating the tunnel, do we have the option of choosing DTLS or TLS?
Yes. We have the option from the VSmart, VManage, not option with the VBond. I'll show you.
Okay.
We
Okay.
when we create the controllers, we have the option. You want to create with a DTLS or TLS? I'll show you.
Okay.
Okay.
And just one more thing, this underlay reachability can be via internet or via MPLS, or is it dependent like we should have only internet reachability?
No,
Like we can have
any transport.
any
Only
transport.
yeah.
Yeah.
It's the either IPv4 or IPv6. They are going to build
Okay.
the underlay. After that,
Okay.
we just have to run the overlay.
Normally, the recommendation is which transport should be used for this underlay first to build the tunnels. Like there is a dependency or there is a criteria like it should have minimum this latency, this jitter for the reachability to
Seriously,
the
actually,
controller.
what happened earlier, why SD-WAN is too successful nowadays, and everyone talking about that. First, we have to understand that
One
before
of the reason is like
yeah,
MPLS was
yeah,
expensive.
before 2015 and 16, our internet was not that much reliable, right? Their SLA was not
Correct.
good, right? So because it's so popular, because everyone's saving the cost. So end goal is replace the MPLS, right? To save the cost. So there
Correct.
is no right hard and fast rule. I can say MPLS we should introduce, right, and we can onboard the smooth like connection with the control plane and data plane. No, it's not like that. Internet even have the great SLA, great reliability, and dedicated bandwidth, right? So they have also expected latency. So internet, most of the customer are using, or I can say 80% customer are using the internet circuits and they are working perfectly fine while onboarding the SD-WAN fabric or devices. All right, so there is no hard and fast rule. I can say
Okay.
like we should go with the MPLS or internet. You have the internet, you can go with that onboarding. In this lab also, we can see we can go with the internet transport or maybe the MPLS transport, but this is a simulation environment. It is not going to make any sense. But in the production also, if I have the ISP from the India, if I am the Geo or Airtel or maybe the I can simply take the connection and they are very good. Even if we take the normal broadband circuits, we are getting the like 300, 500 or 600 Mbps internet speeds without any problem with a very less latency. Okay.
One last query
Yes.
from me also. Like I can understand like vBond is for authenticate and vManage is to configure things,
Mm-hmm.
and vSmart is a control like it controlling the actual routing or policies. But other than that, it can be used only for troubleshooting. Like we want to trace anything or we want to. Uh,
Oh, means you were talking about the VSmart?
yes, yes,
No, no,
vSmart.
no,
Other
no.
than
You
that, we
don't have to
don't.
do any trace. You don't have to do any kind of the trace from the V Smart.
Mhm.
All trace is going to initiate from the branch location. This is just act as a, you learn with the BGP, route reflector,
Yeah,
RR.
yeah, 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 yeah.
Yeah. So this is just acting as a exactly route reflector. Nothing more than that. It's a RR.
Okay,
Means
so yeah, so
it is
we
going to take a
actually
route
not do
from you.
anything on the vSmart. We can check things on the vSmart, but we don't do anything on the vSmart.
Yes, we can check the routing. You want to check
Yeah,
the routing, whether I'm receiving route from the VH or not, I'm
yeah,
sending to
yeah,
this router or not.
yeah.
But actual trace, if you're going to take, it is not going to make any sense. Means you have to initiate traffic from here, right? This
Mhm.
router to this router you have to reach. Then your traffic is not going to happen via this way, right? Your traffic is going to happen via this way directly.
No, so through vSmart we can log in into that VH4 something device, and then
No,
we
no, no.
can
You
do.
don't have to log in anything from the VSmart. Only you can check the routing from here, whether
Mhm.
I'm receiving the route from branch or I'm sending or not. RR is just route reflector, okay?
Yeah.
So you can just get the routing. It
Mhm.
is going to tell you, let's suppose I advertise this route 13, 13, 13, 13, okay? So this
Mhm.
is going to reach the VH3. Further,
Mhm.
VH3 cannot send this route directly to VH4. It has to send via OMP because we not have the OMP. You can see we not have the OMP. OMP between the VSmart to the VH router, right? So
Mhm.
it will send route to the VSmart. VSmart further, if I have the OMP, then it will going to send to this. This router will come to know if I want to reach this, they will get the T-lock. T-lock is the next hop.
Mhm.
Similar BGP, you require the next hop, right? So it will
Yeah.
get the T-lock. Based on that T-lock, if he want to reach that, he will redirect you go with this transport directly via the IPsec tunnel. So his job is done. So nothing more than that. He will just send the route and he will get the next hop and go with the IPsec tunnel. That's it. No worry, you will understand 100%. It's my commitment. Once you
Yeah.
do the lab, you'll see how it is going to happen. So I'll explain what is a T-lock, how the next hop has been changed, how T-lock is going to look like. So we all understand very easily. But this VSmart is no trace, no nothing. You can just do the basic routing checks. Simple RR.
Yeah. Okay. Like BGP. Oh yeah.
Yeah, like this. Exactly in the BGP.
Yeah.
Okay. So thank you so much, guys. Let's meet on the Friday. Okay. Bye bye. Take
I
care.
pasted that link on the chat if someone wants to go through.
What?
That Cisco link which you said like you need for.
Yes. Already I opened it. Okay. I'll read it. Okay. Thank you so much, Jay. Okay. I really appreciate that.
Okay, thank you.
And one
Yeah,
more thing, like
Vishal.
you have shared some video on the like shade through the shade folder
Video
on
means
my.
the same class recording video.
Yes. No, no, no. I
Hmm.
think you have already shared some one video.
Yeah, that probably support team shared that you guys for the last class recording, right?
Yes,
Okay.
yes, yes.
Yes.
First
So you all will
recording.
get the all recording video. Okay. So
Mhm.
probably it is going
Can
to
we
available.
download it or should we only
No,
need
you
what?
you initially watch via the Google Drive. It will be available on the app, our app, and the portal also. So you can just log in and you can watch in the app or might be the website directly.
But we cannot download it, right?
Yeah, downloadable might be restricted.
Yeah. Okay. Okay, I
Okay.
thought it is with
Yeah,
me only.
yeah.
Vishal,
Alright.
just one more thing. The PDF or the PPT which you were showing, like, is it possible to share that, or like
Yeah,
when will?
PDF all definitely you guys are going to get that. PPT I'll convert in the PDF. I'll share that. Okay.
Okay, okay,
Okay.
sure.
Okay.
Thank you.
No problem.
Yeah. Thank you.
Thank you so much. Bye. Bye.